Welcome back to my chemistry lectures on Hess law. And so in this video, I'm going to explain, calculate the standard enthalpy change of formation of carbon monoxide. So by using Hess law. Instead this we have calorimetry also. Calorimetry, calorimetry and Hess law both are the methods. They can help us to find enthalpy change, standard enthalpy change of reactions. So by using direct methods, right? But what is the difference between Hess law and calorimetry? So where calorimetry fails, there we use Hess law. In the sense, calorimetry only can help us to measure enthalpy change of reaction in direct method or in direct steps, but Hess law can help us to measure the enthalpy change of reaction in direct steps. So for that we'll take example of calculate the standard enthalpy change of formation of carbon monoxide. Look at this reaction. In this reaction, carbon in the form of solid burning with oxygen means it is nothing but combustion. So combustion reaction. So carbon is burning by consuming oxygen to form carbon monoxide. Carbon monoxide, so which is incomplete burning, already you know. The same carbon and oxygen combined to form mostly carbon dioxide is the stable product. It is a main product. Whenever carbon burn, directly it can produce carbon dioxide. So enthalpy change for this reaction is, so delta CH standard enthalpy change is how much? Minus, so 393 kilojoules per mole. Which is a negative sign, indicate exothermic reaction, already you know. And the same carbon dioxide can be produced from carbon monoxide gas when undergoes complete combustion to form carbon dioxide. So it can produce enthalpy change is minus 283 kilojoules per mole. So carbon dioxide can be obtained by two routes. The first route is carbon plus oxygen to form carbon dioxide, which is direct step, and whereas carbon monoxide produced to form carbon dioxide, so indirect step. This is another one. These are the known values for the formation of carbon dioxide enthalpy changes. But what we don't know, the same carbon monoxide can be produced from burning up carbon and oxygen. Enthalpy of reaction, enthalpy change of the carbon monoxide, we don't know. Only we know standard enthalpy formation of carbon dioxide by root 2, root 1. So by using the data, by using this, so formation of carbon dioxide by two routes, and we can calculate enthalpy change. So we can calculate enthalpy change of carbon monoxide. So what is given and what is, so how to use Hess law here. Now let me discuss here. Now, if we go in detail of this question, what is given here? So, enthalpy change, standard enthalpy change of combustion of carbon dioxide in direct step. So, how much it is given? Minus 393 kilojoules per mole is given. So, this part. And what we should find out? Calculate the standard enthalpy change of the carbon monoxide. We should find out from carbon and oxygen, right? So here we have to use Hess law. So what is Hess law here? Hess law can be stated as the total enthalpy change for the reaction. Total enthalpy change of the reaction remains same regardless of the enthalpy change of reactants taken the route to form the products. In the sense, total enthalpy change of reaction to form the products from the reactants is equal to enthalpy change of reactants to form products in multiple steps. So that is the definition of Hess law. And now here is, so the total enthalpy change in direct step, how much the total standard enthalpy change of carbon dioxide is equal to, so standard enthalpy formation of carbon monoxide, this we don't know, and standard enthalpy formation combustion of carbon monoxide we know, minus 293, already we discussed it. So now here is a formula we can get. So enthalpy formation of carbon monoxide and standard enthalpy combustion of carbon monoxide. So now you can substitute the values. So this value we don't know, this value we know, and this value we know. These two values, but this value is question mark. Now substitute the values. Minus 393 equal to, so enthalpy formation of carbon monoxide plus, so standard enthalpy combustion of carbon monoxide, this is. So then if you solve this, you get how much the value standard enthalpy formation of carbon monoxide is minus 110 kilojoules per mole. So, and we get standard enthalpy of carbon plus oxygen subjected to burning, we get carbon monoxide gas, enthalpy change is minus 110 kilojoules per mole. I hope you understood. Thank you.